Okay, so now I want to find the tangent line to this curve. And the key is going to be the following. The gradient, this is the thing, one of the things we talked about, the gradient. The gradient is perpendicular to level curves. Okay, so we have a function, f of xy. So in this example, we have a function, f of xy is equal to xy squared, and we have a particular level set, the level set 1. F of xy is equal to 1. Okay, so we want to find the tangent line to this curve. And remember, when you want to find the parameterization for a tangent line, you need two things. You need a point on the line, and you need a vector that is in the same direction of the line. Okay, so we know the gradient is perpendicular to level curves. So since we're dealing in R2, we just want a vector that is going to be parallel to the level curves. Okay, so that's going to be our direction vector, and 1, 1 is the point on the line. So the direction vector, which I'll call V, is going to be any vector that is perpendicular to the gradient of f evaluated at 1, 1. And I will let you compute this. This is just equal to 1, 2. Okay, so for example, we could take v to be equal to minus 2, 1. This is a vector. This vector, minus 2, 1, is perpendicular to this vector, 1, 2. And then so a parameterization for the line could be given by L of t is equal to a point on the line, 1, 1, plus t times v, which is minus 2, 1. Okay, so I just said find the tangent line to the curve. This is one expression for the tangent line. This is a parameterization of the tangent line. But remember, we also have a normal equation for the tangent line. So this is a vector parameterization. But remember, we can also find a line in the form of y is equal to mx plus b, or we could write it as ax plus by is equal to c. The ax plus by equals c form, this is analogous to the normal equation for a plane. So I'm gonna find this equation, and I will let you all figure out how to change it into this equation. So remember, how do you do this? Well, just like with a plane, the vector AB is any vector that is perpendicular to the line. Well, what's a vector that's perpendicular to the line? Well, let's come back up here to this observation. The gradient is perpendicular to level curves, meaning the gradient is perpendicular to the tangent lines. So the gradient is perpendicular to the tangent line. So we'll take the vector to be 1, 2. So then for this particular problem, AB is equal to 1, 2, or any multiple of 1, 2. Okay, so then an equation for the tangent line, a normal equation, would be x plus 2y is equal to c. And how do we figure out what c is? Well, we just plug in an x and y that lies on the line. And we know that the point 1, 1 lies on the line, lies on the tangent line. So then c is equal to 1 plus 2 times 1, which is equal to 3. And so then the normal equation for the tangent line would be x plus 2y is equal to 3. And then I'll go ahead and do this. If you want to write this in y equals mx plus b form, let me change to blue. You can just solve this for y. And so this becomes y is equal to minus x plus 3 divided by 2. Okay, I also want to illustrate this just by drawing a quick graph. So let me scroll down some. I'm going to draw a graph, and then I'm also going to show you on Desmos. So the graph of, if you look at the relation xy squared equals 1 The graph looks something like this. Okay, and we want to look at this point right here. So this is the x-axis. This right here is the point 1, 1. Okay, the gradient vector, this would be the gradient vector, though that's not a very good drawing. This would be the gradient vector. Note that the gradient vector is perpendicular to the curve here, and precisely what that means is that the gradient vector is perpendicular to the tangent line. And so this green line represents the tangent line. This green line segment represents the tangent line. Okay, so let me show you in Desmos really quickly. Okay, so here's the same graph, but in Desmos, so it looks a little bit nicer. So the red part is a graph of xy squared is equal to 1, and then this blue line segment is the tangent line, or part of the tangent line at the point in question. And then right here, I can't really, because of the way Desmos works, it's hard to draw a vector, but the gradient vector would be the vector kind of going in this direction that starts at this point and is perpendicular to the blue line. Okay, so just think through some of these things as you do the rest of the problems. I won't go into this much detail for the rest of the problems.